Hi, my name is Pei, and I'm going to introduce our paper called Commonsense-Focused Dialogues for Response Generation and Empirical Study. This is in collaboration with my co-advisors at USC, and many of this work was done when I was interning at Amazon Alexa AI. So we want to start with the motivation that we find that people from communication studies have argued that effective communications require reaching mutual beliefs and knowledge among participants, and this is a process that is called grounding. So we also find that furthermore, common sense is an important aspect of it. So common sense, which can be defined as the basic level of practical knowledge and reasoning concerning everyday situations and events that are commonly shared among most people, is a critical role in grounding in communications. So we basically find that to be able to reach some common ground or be able to reach some mutual knowledge that are shared with you and the other participants in a dialogue, you will need to use your common sense to reason and produce inferences from the other person's utterances and to make your own response that makes sense and coherent. So common sense is crucial for grounding, and grounding is crucial for communications. So we want to raise two research questions in these dialogues, in the common sense in dialogues. So first is, can we identify and evaluate common sense in dialogues? And the second is that do AI models benefit from dialogues with more common sense involved? So to start with, we definitely need data. So we want to propose this what we call as the common sense focused dialogues data. So we have considered several criteria for it. The first is we want it to be in an everyday chatting scenario, and we want it to be in an open domain setting. And the other is that, so what is common sense focus defined, right? So we want to see it contains interesting common sense guided common grounding, especially in the dialogues and responses there. So some examples that show this common sense guided grounding is that the responses you're producing is to be relevant to the context, and also to be produced empathetic responses also require common sense. You will need to know that the person is feeling happy or sad, and that requires social communication skills. And the other is that normally when we make responses, we're in our mind, we're implicitly making many valid inferences that starting with our common sense to make the response that the other person can expect, or just as coherent to make the dialogues moving. And lastly, we also want the data to be multi-term. So to start with, we want to look at some existing resources on both dialogue ends and the common sense reasoning ends. So to start with, we consider, of course, there are many existing dialogue data sets, such as daily dialogue, persona chat, empathetic dialogues, etc. And we also look at some of those common sense reasoning benchmarks, which is a more focused one that target reasoning ability for common sense. And we find those are mostly, I think, multiple choice questions data sets, such as SocialIQA and Commonsense QA. And lastly, we also consider existing knowledge-based knowledge graphs that are talking about common sense knowledge, for example, consonant anatomy. However, all of this has some sort of lacking between what there's a gap between that and what we want to be a common sense focused dialogues. For the existing dialogues, we're not sure that is there common sense in there. So like there may be some dialogues that are more trivial that require some more specific knowledge. But of course, there are also some dialogues that may require common sense. So we need to find a way to locate and find them out in these existing data sets. And for those common sense reasoning data sets, the problem is that they are mostly multiple choice questions format. So they're not talking about in a dialogue scenario, and they're not asking the machine to generate, but they're asking the machine to choose from a list of candidates. And lastly, for these knowledge resources, they're not connected to data sets. They're good resources, but we cannot evaluate and test machines' ability about can we make commonsensical responses using just the resources alone. So we have thought about first, can we start finding or evaluate some of the common sense in these dialogues here? And we propose a simple method considering those three data sets we have found here. The first data set we to use is the daily dialogue, which is, I think the person says that reflect the daily communication and cover various topics about daily life. And the second data set we consider is empathetic dialogues, which is more focused on empathetic dialogue response generation, grounded in an emotional situation. And this data was crawled from Amazon Turking. And we also consider mutual, which is, I think, what they mentioned as the first human-labeled reasoning-based data set for multiple turn dialogues. And this is actually a response selection dialogue data set. And then the data was actually crawled from Chinese students' English comprehension exams. So our goal is trying to see that can we, in this existing dialogue that contain many dialogues, can we do filtering the dialogues that are considering interesting common sense, that consist of interesting common sense. So the goal is kind of focus on dialogues in them that demonstrate common sense. And then we propose a simple heuristic approach to filter such dialogues. So for each turn, we first come up with a list of candidates by identifying the nouns, verbs, and adjectives in the turn. And then we query a common sense knowledge graph, such as ConceptNet, to find, okay, what are the, all of the candidates, what are the actual some concepts in the graph. And then lastly, we determine if a subsequent turn has a one-hop edge between the concepts in the current turn and the next turn. So if there's an edge, as an example here, like I am sleepy, I can hardly keep my eyes open. Why don't you go to bed? And the person says, I think I will. So in this case, we find we're able to match the triple in ConceptNet, which is bed related to sleepy, to the two concepts, one in the previous turn and one in the next turn. So this is a way just trying to see that, okay, if the previous utterance has mentioned some concepts and the next utterance has mentioned another concept that has one of the common sense relations in the common sense knowledge graph, we use this as a filtering, as a simple way of heuristic to focus on the common sense in this dialogue. So the results we find that is that for 3 dialogues, we have done the filtering. For daily dialogue, we find that around 63% dialogues exist, at least have one of the triple that can be matched in the dialogue, as we shown before. And for empathetic dialogues, the number is 53%, and for mutual, number is 73%. So this regarding to filtering, but we also consider another way of collecting the common sense focused dialogues, which is we want to collect from common sense reasoning datasets, because as I mentioned, those datasets are targeted very specifically for common sense reasoning capabilities, but they're not just in a dialogue scenario. So what we do is that we prompt Amazon Turking platforms using SocialIQA, which is a dataset, one of the dataset that focuses on social common sense. And when we use SocialIQA context, we ask them to write multiple multi-turn dialogues between 2 friends. So each of the SocialIQA instance comes with a triple, which is a context, question, and answer. As an example here, we find that Alex spilled the food she just prepared all over the floor, and it made a huge mess. And the question is, what will Alex want to do next? And the right answer is to mop up. So we chose this dataset because the context is actually rewritten from Atomic, which is another knowledge base, another common sense knowledge base that contains inferential knowledge about causes and effects about 24K short events. So in this case, we're trying to assume that maybe if we convert those into dialogues, some of those dialogues will also explore some potential cause and effects events about this particular event that is in this context here. So this is our crowdsourcing task format. Basically, we're giving each worker the context from SocialIQA, and we're trying to see that, okay, imagine that you are the person, Alex, describing the context. You're talking to your friend about this event in the context. Please write a short dialogue where you describe the context in your own words to your friend and their responses or reactions. So we basically want to prompt them using this context. You need to first describe the event, describing the context, and then start a conversation where your friend gives feedback or gives responses to this event and continue the dialogue. So we're able to collect 24.5K common sense focused dialogues here, and the average turn number is 6. And here I'm just to show one example of the dialogue we have collected from SocialIQA. So we actually asked multiple workers to write a dialogue given the same context, because potentially one event can lead to many different dialogue directions. So the context is Tracy performed her function, their employer gave them a raise. And the one person writes the dialogue as, I got a raise today, totally unexpected. My boss told me I was doing a great job. And the friend says, it feels good to be rewarded for hard work. So in this case, we find that in this simple first turn, the friend's response can actually show some interesting common sense inferences here already. For example, like getting a raise indicates that the person definitely will be feeling good. So this also relates to empathetic responses. And also getting a raise is possibly a consequence of being rewarded for hard work, or that requires rewarded for hard work here. And actually another worker writes this, given this context, writes a different dialogue here. The Tracy said, get dressed, we're going out to celebrate my raise. The friend says, awesome, what did your boss say when you got it? Tracy says, she said I did my job very well and deserved it. And the friend replies, you should be so proud, you've earned it. In this case, we also find that the mentioning of the concept boss is actually sort of you need to have a boss in order to get a raise. And also being so proud, feeling proud is also a proper empathetic response of the event that the person is getting a raise. So these are just some examples that showcase that this kind of dialogues, we're able to show that some common sense interesting inferences and reasoning paths are embedded in the responses in the dialogues here. So I think those are the first part that was really talking about the data we have collected, because we need to start with data. And the second research question that I was talking about is that we want to see, can those data help model to perform better or more coherent responses? So we train the same GPT-2 model on different data set settings. First three is that we just train on some existing data sets, daily dialogue, empathetic dialogues, and topical chat. And the last three is, I think, from our efforts, and which is we first consider the filter version of some of the three existing dialogue data sets, and we refer to it as filtered existing or FE. And we also consider the filter version combined with our cross-sourced every data dialogues from SocialIQA, the total 25K, and we refer to it as FE plus cross-sourced. And lastly, we also conduct our filtering approach on the collected SocialIQA dialogues, and we refer to it as FE plus filter cross-sourced. So the automatic evaluation using perplexity and other scores, basically the main pattern we see here is that we find that applying our filtering approach and then combined with the cross-response, we're able to decrease the perplexity of the test case by a large margin compared to previous just training on existing data dialogues. And also the BERT score indicates that we're able to get more quality results here. But of course, this is not focused on common sense related criteria. So we also apply human evaluation. So for human evaluation, we list a list of 6 dialogues or 6 responses from systems, and we ask them to rate on a scale of 1 to 10. And we especially ask them to see, okay, how plausible is the response in terms of common sense for each of the response. And the results is also similar to what we have found, that we find that those filtering techniques can actually help produce the dialogues that are more common sense focused, and the models trained on those dialogues specifically will get to produce results that according to human, making more common sense from the average score absolute increase about 1 or 2 points. And we're also able to reduce the variance of the results quality by 3 or 4 points. However, of course, we're still having a huge gap behind human responses, which is still, I think, 3 points, like around 3 points ahead. So for this, I'm going to talk about this briefly, but we also propose a simple, scalable, common sense targeted metric for response generation that is automatic. So basically what we do is that we train a simple regressor on our 300 collected human scores with these several features. We consider some symbolic features, which is also close to our filtering technique. We consider the number of one-hop links with the response and the previous term, number of two-hop links, as well as we consider some newer features. We just use a dialogue GPT model score to as one of the features. And we can see we are able to reach higher experiment correlation with some previous approach, and also just consider the different features by ourselves. But still, the correlation is not high enough. So the main takeaway, I would say that the first is that the analysis and evaluation of dialogues with common sense knowledge base resources is possible and effective. And we find that common sense focused dialogues are helpful for models to generate responses that are more coherent. And lastly, we'll find that a simple metric trained with neurosymbolic features can show promising results in automatic evaluation of response generation. And lastly, we find that there's also definitely some limitation for this work. I think the main thing is that using mainly concept net-based filtering only concerns word level one-hop matching, which definitely will ignore more complex common sense relations embedded in dialogues. So for future work, we want to see, we want to do deeper analysis of how implicit common sense is represented in dialogues and how to elicit multiple hop granular reasoning steps during communications. Thanks for your time.